There are two planets in our solar system that started exactly the same way, born from the same cosmic dust, forged in the same fires, blessed with the same ingredients for life. One of them became home to 8 billion people, forests, oceans, and endless possibilities. The other became hell, not metaphorically, but literally hell, a world so hostile that our toughest machines survive there for less time than it takes to watch a movie. The difference between paradise and perdition? About 25 million miles. That's the distance separating Earth from Venus, our twin planet that took a very different path. And here's what keeps planetary scientists awake at night. The same fate that destroyed Venus could be waiting for Earth, and we might be accelerating toward it faster than anyone wants to admit. Right now, 25 million miles away, there's a planet that weighs almost exactly what Earth weighs. If you put them on a cosmic scale, Venus would be 81% of Earth's mass. Stand on its surface and gravity would feel nearly identical to what you experience right now. Both worlds have iron cores generating magnetic fields. Both have thick atmospheres wrapping around rocky mantles. Both orbit the same star at roughly the same distance from the cosmic neighborhood we call home. For most of human history, we assumed Venus was our warmer sibling. Ancient astronomers saw those brilliant white clouds and imagined tropical paradises beneath them. The planet shines so bright in our sky that entire cultures built myths around it. The Romans named it after their goddess of love and beauty. We wrote poems about the evening star, dreamed of jungle worlds and alien oceans, built telescopes hoping to glimpse the paradise hiding under that mysterious veil. Then we looked closer, and the dream shattered into 1,000 pieces. The clouds we thought were water vapor turned out to be concentrated sulfuric acid. The paradise we imagined was actually a pressure cooker, where the atmospheric weight would crush a human being like an insect. The tropical warmth was a furnace running at 880 degrees Fahrenheit, hot enough to melt lead, zinc, and tin. There are no seasons on Venus, no day-night temperature variations, no polar ice caps offering relief, just uniform, relentless, eternal heat distributed evenly across every square inch of the planet's surface. And this is where the story gets truly disturbing, because Venus didn't start this way. The evidence is written in the chemistry of its atmosphere, in ratios that don't lie, and isotopes that remember. Venus once had oceans, real liquid water oceans that may have covered the entire planet in a shallow global sea. It had a water cycle, clouds that rained fresh water instead of acid, possibly even a climate that could have supported life. Then something broke, something fundamental, something that transformed a water world into the most hostile environment in the solar system. The Soviet Union spent billions trying to understand what happened. While America raced to the moon, the Soviets aimed their ambitions at our twisted sister. The Venera program launched probe after probe, each one a technological marvel designed to answer a single question: what is Venus really like? The early attempts failed spectacularly. Probes designed for what engineers thought Venus would be like were crushed, melted, or torn apart before ever reaching the ground. But Soviet engineers are not easily discouraged. They redesigned, rebuilt, reinforced. They created titanium spheres capable of withstanding pressures that shouldn't exist on a planetary surface. And in 1975, one finally survived long enough to send back humanity's first photograph from the surface of another world. Not Mars, as most people assumed would happen first. Venus beat Mars to that historic milestone. The image that came back showed a world of broken, angular rocks under a sky glowing with diffuse orange light. No shadows because the clouds scattered the sunlight into a uniform glow. No movement except the slow crawl of data transmission. And then, 53 minutes after landing, silence. The electronics had cooked. The mission was over. Later missions improved on that record. Venera 13 survived for 127 minutes in 1982, long enough to capture color photographs, analyze rocks, record sound, long enough to confirm that the surface was indeed volcanic basalt, that the wind howled across a lifeless wasteland, that nothing lived, nothing moved, nothing survived in that chemical nightmare. Then it too fell silent. Another monument to human curiosity melted into the landscape. Here's what killed those probes, and here's what killed Venus itself. Imagine you're standing on early Venus 4 billion years ago. The sun is younger, dimmer than it is today. The planet has cooled enough for water vapor to condense into liquid. Oceans form, shallow at first but covering vast areas. Clouds form, rain falls, the water cycle begins. For a brief moment in cosmic time, Venus might have looked almost Earth-like. But Venus is closer to the Sun than we are, just close enough to tip the balance. As the Sun aged and brightened over millions of years, Venus began receiving slightly more energy than it could comfortably handle. The oceans warmed, more water evaporated into the atmosphere, and here's where physics becomes cruel, because water vapor is one of the most powerful greenhouse gases in existence. It traps heat better than carbon dioxide. So, as more water evaporated, the atmosphere trapped more heat, which caused even more evaporation, which trapped even more heat. This feedback loop has a name, the runaway greenhouse effect. It doesn't require asteroids or supervolcanoes or alien intervention. It just requires a planetary climate to cross a specific threshold, a tipping point beyond which the physics become irreversible. Venus crossed that line and there was no coming back. The oceans boiled away over millions of years. Water vapor rose into the upper atmosphere, where solar radiation tore the molecules apart. Hydrogen, being light, escaped into space. Oxygen, being reactive, combined with sulfur and carbon in the rocks, and the water that had once covered the planet vanished into space, or locked itself into chemical compounds, never to flow again. Without water to absorb and cycle carbon dioxide, the volcanic gases built up unchecked. The atmosphere thickened, the pressure increased, the greenhouse effect intensified, until the entire planet became a self-sustaining oven. No mechanism existed to stop it, no process to reverse it. Venus had crossed the point of no return, and physics is not merciful to planets that cross such lines. The evidence for this catastrophe sits in the atmosphere today. The ratio of deuterium to normal hydrogen is over 100 times higher than Earth's ratio. Deuterium is heavy hydrogen, the kind that doesn't escape into space as easily as normal hydrogen. When we see excessive deuterium, we're looking at a chemical fingerprint of lost oceans, a ghost signature of water that once existed but was violently stripped away. This isn't ancient history. This is a warning label written in planetary scale physics. Earth sits just far enough from the Sun to maintain stable oceans, just cool enough to keep the greenhouse effect in check. But we're not in the center of the habitable zone. We're on the optimistic side of it. Venus shows us what happens when a planet crosses to the pessimistic side. And here's what should terrify every single person watching this. We're conducting an experiment on our own planet right now. We're adding greenhouse gases to our atmosphere at a rate that has no precedent in geologic history. We're warming our oceans, melting our ice, pushing our climate towards states it hasn't experienced in millions of years. We don't know exactly where Earth's tipping point is, the line beyond which feedback loops take over and human intervention becomes meaningless. But we know the line exists because Venus showed us. And we know that once a planet crosses it, there's no technology, no miracle, no negotiation with physics that brings it back. The Soviet probes that melted on Venus's surface aren't just monuments to engineering ambition, they're gravestones marking the death of a world that could have been beautiful, cautionary tales transmitted across 25 million miles of space. Venus isn't just a failed planet, it's a mirror showing us one possible future, a cosmic warning sign telling us that habitability isn't guaranteed, that paradise can become hell, that life-bearing worlds can die. And the difference between survival and catastrophe might be smaller than we think, a matter of degrees, of atmospheric chemistry, of choices we make now that echo across geologic time. If this changed how you see our fragile blue home, hit that like button. I need to know what you think. Can we learn from Venus's death, or are we destined to repeat its mistakes? Drop your answer in the comments, because this conversation matters more than you realize. If you want more videos exploring the biggest questions in our solar system, subscribe and turn on notifications. And if someone you know needs to understand why planetary science matters, share this with them right now. Thanks for watching, and remember, we got incredibly lucky to be born on the one planet that didn't become hell. Let's not waste that gift.